All right, for this bell work, it's a two-step equation, but it's just got the inequality between, okay? So this one's a little bit different. We did talk about these types last time. We just didn't see any that were like it. But if you can do this one, then pretty much all the ones that we do today or on the assignment should be pretty easy, okay? So the first thing we're going to do on this one, we're going to use principles of equality to isolate the negative 6y. Okay, we don't want that plus 4 there. So we're going to have to zero that out. And remember, we are kind of forcing that to become a 0, which is okay because it's a principle of equality, meaning whatever you do to one side, you must do to the other side as well. So in this case, we're subtracting 4 because 4, that's positive 4 minus 4 here is 0. And then that allows me to drop the negative 6y. Now we know that's a subtraction principle of equality, which never affects the inequality symbol. This one is greater than, but it does allow me to isolate my negative 6y so that it is by itself. Then I got 31 minus 4, which is 27, okay? The next thing that we want out of this is for the coefficient of y to be 1. So how do you make a negative 6 a 1? Well, that's where you would have to, again, to both sides, divide by negative 6. Okay, so I divide both sides by negative 6. And what happens here is you got negative 6 divided by negative 6, that's 1. And that's where this one comes from right here. And then on the right side, you got 27 divided by negative 6, which if you put into the calculator would give you negative 9 over 2. Now, I'm going to keep it as a fraction, by the way. Now, the unique thing about this one, we did talk about it last time, like I said, is that we divided both sides by this negative 6. If you ever need to multiply or divide both sides by a negative, then it flips this inequality. So where it was once a greater than symbol, now it is a less than symbol. Okay? This one's done though. Like we saw in the bell work there is just kind of one extra rule. And here's our objective though. So we did just on the bell work there use two principles of equality to solve the inequality with, again, it's just one small extra rule added to our principles of equality, okay? So I'll take 30 seconds and copy this down, please. All right, so here's our principles of equality. And we got addition and subtraction, which we use in order to make zeros, just like we saw in the bell work, where we use the subtraction principle of equality. Generally speaking, we make zeros first in order, generally speaking, okay? Now, what we have seen also is that in the future, when the equations become longer, we will expect to see some combining like terms or some distribution as well. Okay, so I'm busy, okay. So on this one, we got multiplication and division as well, and we use multiplication and division in order to make ones, okay? So now, not just any ones, but we use these to make coefficients 1. All right, and again, usually we'll do that second in order. All right, it's just, we now have this one little extra rule for using these with inequalities, and that's if we ever multiply or divide both sides by a negative, only by a negative, the inequality flips. There we go. Okay, so if you, just like we saw in the bell work, if you, like we did with, I think it was negative 6, divide both sides by a negative. It's not that it's a 6, it's that it's negative. When you multiply or divide both sides by a negative, then it flips the inequality, okay? So we've already seen it, and again, if you can just understand that part, then this lesson will go pretty good for you, but also doing the assignment as well. So, solving equations. And we did not see any distribution or combining like terms, or if we did, not very much of it. Although we did see both of those extensively in the last unit, or 2 units ago at least. But right here, number 3, it says that's when we use principles of equality to isolate the variable. When we isolate the variable, that's when we make zeros. And then also, when we divide both sides by the coefficient, that's when we make usually ones, okay? Now, yeah, it's possible that we need to multiply both sides by what would be, yeah, it's where we divide, or we'd multiply both sides by the denominator, which we've seen before, okay? Something like, I don't know, x over 4. In these types of cases, you would multiply both sides by 4. If there's some kind of equal sign, this value doesn't matter what it is. But what this does is it makes the coefficient a 1. Okay, so I cross those out, but some students mistakenly believe that I somehow canceled those out. I haven't canceled them out, I just made them a 1. It's just slanted, that's all, okay? So then you multiply both sides by 4, and in this case, we didn't divide by the coefficient, we ended up multiplying by the denominator. If that's needed, then we do that, okay? It's just now this one is saying if the coefficient is negative, then we flip the inequality. Yeah, this one right here, if the coefficient is negative, then flip the inequality. It's just saying if we ever multiply both sides by a negative, then it flips the inequality, okay? But again, we're not expecting to see any distribution or combining like terms yet. So let's do this one. We got x over 3 minus 12 is greater than or equal to negative 8. And we're going to solve this one almost exactly like we did on the bell word. Okay, so we're going to bring this inequality down. Just looking at this one, though, we got this x divided by 3 minus 12 is greater than or equal to negative 8. It's that minus 12 that I got to get rid of so that I can just drop my x over 3 right there. Now, if I get rid of, I'm talking about making it a 0. So I'm going to force that to become a 0 by adding 12 to both sides. Okay, so plus 12 right there, that does make that a 0, but if I plus 12 to one side, I got a plus 12 to the other side as well. And we already know that the addition and subtraction principles of equality do not affect the inequality symbol. So it was greater than or equal to, so it will remain greater than or equal to. But now this allows me to drop my x over 3, and then I do negative 8 plus 12, which is now positive 4. Now we're pretty close. It's just in the end, like we said, we don't want x over 3, we want 1x. So how do I make a divide by 3 a 1? Well, you're just going to have to multiply it by 3. Okay, but if you do it one side, you're going to have to do it the other side. Again, that's really 3 divided by 3, which is a coefficient of 1. Now right here, I multiplied both sides by a positive 3. The positive 3 makes the inequality remain a greater than or equal to symbol. If that 3 were negative for some reason, then I would have had to flip the inequality. And now I can do 4 times 3, which is 12. So I get x is greater than or equal to 12. And that's it. All right, this one, again, the process is essentially the same, but this one will have the one exception that we are looking for today. So the inequality, maybe we'll drop it, maybe we'll flip it, we'll see. But the first thing I got to do is get rid of that negative 8. Okay, so I'm going to zero that out. And a negative 8 plus 8, that will become 0, just like we want it, just like we are planning to do. It's just, if I do it one side, I got to do the other side. Okay, so that will zero that out. Now I am dropping this. It's not just 4x, you guys. It's that minus sign that makes it a negative 4x. And since we use the addition principle of equality, again, that does not affect the inequality symbol. But then I can do 64 plus 8, which is 72. Next, I don't want this to be negative 4x's. I want 1x's, okay? So to make that negative 4 coefficient of x a 1, I'll have to divide it by itself. Okay, so divide that by negative 4, but if I do it to one side, I'll have to do it to the other side as well. And so negative 4 divided by negative 4 is 1. That's our 1 coefficient of x. But then I got 72 divided by 4, which would result in negative 18. Now, one thing you'll notice on this one is that I did divide both sides by a negative, so I have to be careful just dropping that inequality. Since I did divide both sides by the negative, I need to flip the inequality, okay? So no longer is it less than or equal to, it is now flipped into greater than or equal to. But that pretty much is it for this one. All right. You know, you guys try this one out. Take a minute, try it out, then we'll go over it, okay? So, just like we've seen before, the first thing I want to do on this one is to isolate the x's here. Because, yeah, there is no need for distribution or combining like terms. So that means this negative 4, it has to go. So I have to make it a 0 by adding 4 there, okay? But again, if I do it to one side, I'm going to have to do it to the other side as well. Okay, so negative 4 plus 4, that is 0. And then that allows me to take the negative 3x and drop it. Again, it is a negative 3x because of the minus sign. And there's the addition principle of equality, so it does not affect the actual inequality symbol. Okay, so I got a less than or equal to symbol. And then 35 plus 4 is 39. Okay. Next up, so I made a 0. Again, the idea here with our principles of equality is then to make a 1. In this case, 1x. So how do you make a 3x, a negative 3x, a 1x? Just divide it by itself. Okay, so if I do it to one side, I got to do it to the other side as well. Okay, so yeah, negative 3 divided by negative 3 is 1. And then 39 divided by negative 3 is negative 13. Now, again, we see on this one that we divided both sides by the negative, which indicates that when we drop this inequality, it needs to flip into a greater than or equal to symbol. But now that I have a coefficient of 1x and it's isolated, it's all by itself, nothing added or subtracted to it, that's just it. This is done. So on this one, we got 2 minus x divided by 4. So yeah, it is greater than 9 on this one. And it's 2 minus, okay, so we got this 2 right there. That is going to need to be zeroed out. So that, I can just drop this as a negative x over 4. Okay? But the 2 is going to have to go, meaning I'm going to have to make it a 0. So minus 2. But if you do it to one side, you got to do it to the other side as well. So 2 minus 2 is 0. Again, this allows us to drop this. It's a negative x over 4. And that's the subtraction principle of equality, so it's not going to affect the inequality symbol. 9 minus 2 is 7. Now I've got this as a negative x over 4. I'm actually going to assign that negative symbol to the 4, just so I can get rid of both the negative and the 4 at once. Now I guess I said get rid of. Really what I'm going to do is make that a 1x instead of a x divided by negative 4. Okay, well, how are we going to do that? Because we do need to do that. Well, just like we saw before, right here, I'm going to need to multiply by negative 4. Just, if I do it to one side, I'm going to have to do it to the other side as well, okay? And then negative 4, this really is negative 4 divided by negative 4 right here, which, again, that's why we get a 1 right there. So that does give me this 1x. But then we got 7 times negative 4, which is negative 28. It's just, I think some of you noticed right here, we multiplied both sides by a negative, which when we bring the inequality down, flips it into from a greater than symbol to a less than symbol. But again, now that we have 1x and there's nothing added or subtracted to it, well, that's pretty much done. So this one has some, I guess, some big values in here, particularly the 109, right? But whether the numbers are big or small, it doesn't really matter. The process is the same, okay? So what I'm talking about here is this negative 5x. I want to isolate that by just being able to drop negative 5x's. Meaning I do not want 109 there. So how do I make it go away? Make it a 0. Just like we saw with the principles of equality here, I'm going to subtract 109. So the minus 109, if I do it to one side, I need to do it to the other side as well. Okay, so I got negative 6 minus 109. That's going to give me negative 115 right there. And this is just minus 109. So again, that's a subtraction principle of equality. That does not affect the inequality symbol. So I still got negative 5x is less than negative 115. Now on this one, just like on the previous ones, we want 1x's, not negative 5x's. So we need to make that negative 5 coefficient a 1. And to do that, well, just going to divide it by itself. Just if you do it to one side, you got to do this to the other side as well. Okay, but you'll notice again, we did divide both sides by a negative here, which means that the inequality needs to flip into a greater than symbol. Okay, so negative 5 divided by negative 5 is 1, just as we planned, just like we forced it to be. And then negative 115 divided by negative 5, that's going to be a positive value. Looks like that's going to be 23 right there, positive 23. Now the question has come up where it says that we say, well, this negative 115 is negative, which is why we flip the inequality. No, the negative 115, we don't care if this value is positive or negative. We care about the number we're dividing by. In the past, we call that a divisor. So if your divisor is negative, at least when you're using principles of equality, you have to flip the inequality, okay? So in this case, x needs to be greater than 23. Any value greater than x, greater than 23 in the original equation here would have made it a true statement. All right, again, there's our objective. I can use two principles of equality to solve inequalities. It's just with that one minor exception, one extra rule with principles of equality in inequalities. If you ever multiply or divide both sides by a negative, then you need to flip the inequality.